In this activity, we're going to look at the area of squares and square roots on a geoboard. Instead of actually using a 5x5 geoboard, I'm going to use images of the geoboard because it'll be easier for you to see. Now on the 5x5 geoboard, that's 5 pegs by 5 pegs, there are 8 different size squares. So let's find them. Okay, I have a 1x1 right here. So I can say that the area equals 1, and they're centimeters squared. And the length of the side is 1 centimeter. Here, I notice that I have one, I can do it this size. It's 2 centimeters by 2 centimeters. Okay? And so my area, if I kind of dot this in, you can see I have 4 little squares. So my area is 4 centimeters squared, and the length of each side is 2 centimeters. Down here I'm going to draw another one, which I see is 1, 2, 3 centimeters by 3 centimeters, little pegs. And so my sides are 3. And if I draw these, kind of dot them in, then we see that I have 9 little squares. So my area is 9, and the length of my side is 3 centimeters. And on this last one here on this paper, I can go 4, it's 4 spaces by 4 spaces. And so the length of my side is 4, and when I draw in the little squares, these little 1 centimeter squares, then I see that my area is 16 centimeters squared, and the length of each side is 4. This is 4 centimeters. Okay, because we know that our formula for the area of a square is side squared. But when we go backwards, and instead of writing out the question, what is the length of the side of the square whose area is, let's say, 16, we can just use a shorthand notation that says the square root of 16 is 4. So this means it's a shorthand way of saying that if we have the area of the square already, we want to know the length of the side. Okay, so likewise over here, I could say that the square root of 9 is 3, because I'm asking, what is the length of the side of the square whose area is 9? That's what this means right here. Now we're going to look at the other 4 squares that are on a 5x5 geoboard. Now I'm going to look for the other 4 squares that are on the geoboard that are of different size than the ones I already have. And one of them can be found like going diagonally like so. And I see that that's a square because the sides are the same. It's diagonally through the corners. And then the question is, how do I find the area of the square? What I realize is I can divide this up like this. And it gives me 4 little triangles. And I see that the triangle is half of this square. And this triangle is half of this square. This triangle is half of this one. And this triangle is half of that. So I have, this one is a half, this one is a half, this one is a half, and that is a half. So I have 4 halves. So the area of my square is 2. It's 2 centimeters squared. So then my question is, what is the length of the side whose area is 2? So that we know is the square root of 2. So we said the square root sign is the answer to the question. That's the length of the side whose square is that number. Okay. So we have another square we're going to find, and that's another one is this way. And to find the area of this square, I see that I have these that I already know are halves. So I know that this is a half, and this is a half, so that gives me 1, 2, 3, 4. So I have 4, and then in the middle, I have those 4 squares, so that gives me a total of 8 squares. So the area of that larger square is 8 centimeters squared. The length of the side of the square whose area is 8 is the square root of 8 centimeters. Now some of you may have noticed that this length is twice as big as this one. So here is 1 square root of 2, and here's another square root of 2, so that gives me 2 square roots of 2. So if you see it like that, the length is 2 square roots of 2, but the other way we looked at it, we saw it was the square root of 8, so we know that those two are equal. 2 square root of 2 is the same as the square root of 8. The next 2 squares that I'm going to find and then find the area of are a little tricky. Let's see, one is here. It's right there. Now I want to find the area of that square, and in order to do that, it's going to involve some triangles like the previous ones, but I'm going to draw this big square around the square that I want to find the area of. So this large square, the length is 1, 2, 3. So I know the area of my large square is 9. The pink one is 9, and I'm going to subtract away the pink triangles, or the area of the pink triangles. So how do I find that? Well, what I see is, if I do this and I make a rectangle, then the height of this rectangle right here is 2, and this length is 1. So that gives me an area of the rectangle is 2. Since I want just, I'm going to take away the pink part, so the area of the pink part is going to be 1. So the same thing here, The area of this is 1. The area of this is 1. The area of this one here is 1. The area here is 1. So that gives me 4 little triangles I'm going to remove. So then the area of my square is 9 minus 4, which is 5. So the area is 5 centimeters squared. What is the length of the side? The side is the square root of 5 centimeters. And now the last one that's hidden here on the geoboard is right there. In order to find the area here, I'm going to look at the big square. Okay, the area of my large pink square is 16. Then I'm going to take away the area of the triangles. And I know that the area of the triangle is 1/2 the area of the rectangle. So then the area, the length of this rectangle is 1, 2, 3. The height is 1. So the area is 3/2. But if I put 2 together, then any two, these two together, will give me 3. These two together will give me 3, so that gives me 6. And so the area of my square on the inside is 10 centimeters squared. And so the length of each side is the square root of 10 centimeters. So one more thing I want to look at is that we said we can have the diagonal of the square, the length is the square root of 2. And I can draw another square root of 2. I can draw another square root of 2. So this gives me the square root of 2 plus the square root of 2 plus the square root of 2 gives me 3 square roots of 2. I can add them together. The diagonal of the rectangle like this is the square root of 5. So if I do it again over here, it's another square root of 5, and I see I have 2 square roots of 5. So I have the square root of 5 plus the square root of 5 gives me 2 square root of 5. But what if we put them together? What if we have, let's say, the square root of 5 here, and I want to add the square root of 2. And I'm going to have the square root of 5 here, the square root of 5 plus the square root of 2. What do I get? And you notice what I get is a crooked line. Here, it's a nice straight line. I can add them together because they're the same. Here, I can add the square root of 5 and the square root of 5 together because they're the same. So I get 2 of them because they're the same. They're square roots of 5. But here, when I go to add a square root of 5 and the square root of 2, I can't add them together because they're different. And my line is not going to be straight. So I can't add the square root of 5 and the square root of 2 together. And that's what we can show using the geoboard, why the radicand has to be the same in order to add them together. And that concludes this video. Thank you.